Hi everyone, welcome to Kafka um, tutorial walkthrough. I'm inside the Kafka distributed system directory where you should see the Docker compose YAML file, a producer, and a consumer. Let's set up the Docker by running Docker compose up. I will wait for a bit and go to a separate terminal where I run Docker PS to check on the status of our Docker containers. And you see that they are up a few seconds ago. You should see 5 different containers. The first one is for Kafka, which is an UI where we can see the state of our Kafka cluster, 3 Kafka brokers, and 1 zookeeper. For the purpose of this tutorial, I keep the Kafka cluster simple by only include 1 zookeeper, but in production, normally you used to see 3 zookeepers. And right now, let's go into the port of Kafka to see our cluster. And it's available through localhost 9000. And here you can see that we have 3 brokers, 1, 2, 3. The current controller is broker 1. You should not see, we don't see any topics here because we haven't created any for our Kafka cluster. But once we start running the producer and the consumer, topics should appear. So right now, I will run my producer file. And this producer is doing the job of creating different Facebook profiles with user ID and follower number. Opening a new terminal tab and run Python 3 consumer.py. The logic is that if the number of followers pass a certain threshold, that Facebook profile will be categorized as famous. Otherwise, it's a normal Facebook profile. And you can actually see those topics when coming back to Kafka UI and see that we have a producer topic here where our producer send data to. And in Kafka, the consumer will pull data from this producer topic and categorize to either famous topic or normal topic. So everything looks good for now. And let's go ahead and start our first experiment. The first experiment is to start a controller broker. Because the hypothesis is that after you start the current controller broker, zookeeper will do the work of select a new leader and replace the dead controller with a new controller. And our program should run like normal after the leader selection. Just to make sure, you can check the current controller inside the zookeeper command line interface as well, because sometimes CapDrop would not be accessible if our controller are stopped. So first of all, I will open the bash shell for the zookeeper. Now I'm inside the bash shell, and if you check the directory, you will see a file called zookeeper like this. Let's get access to this file, go to the bin directory and run and open the command line interface file. Once you're inside the command line interface, you can just do a simple get controller to get the current controller. And the current controller is broker 1, which is consistent with what CapDrop told us before. That's a good news. As you can see here, my producer and consumers is still working, are still working. And now we will start the first broker, which is the controller broker. I actually would pause it instead of completely stopping it. Pause it. As you can see right now, our controller broker is paused. And when I go back to the consumer terminal, I still see it running. And it's a good news, our system is still running. However, to make sure that it's not the residual of the old system, I will close down this terminal tab and open a new one to run the consumer file. And it's still running. If the hypothesis is true, then when I check on the Zookeeper command line interface, I should see a new broker get selected as a leader. Get controller, and now you can see that the new controller broker is 2. So Zookeeper actually did the job of selecting a new leader. That's it for experiment 1.